Rectangular vector components of force. Let's see how to find rectangular vector components of force with the help of this example. A tow truck is pulling a car from a ditch. The tension in the cable is 20,000 newtons at an angle of 40 degrees to the horizontal. Draw a diagram showing resolution of forces into its rectangular components. Determine the magnitude of horizontal and vertical components of the force. So let's say this is our horizontal, right? And then we have a force of 20,000 newtons acting at an angle of 40 degrees. Now since it is being pulled, let this be the force of 20,000 newtons. So we'll write 20,000 here. It makes an angle of 40 degrees with the horizontal. So that's the diagram. So this diagram shows the force. Now we need to resolve this force into its components, and we can resolve it into its horizontal and vertical components. And these horizontal and vertical components are at right angles, and therefore we call them rectangular vector components, right? So the question is, draw a diagram showing resolution of forces into its rectangular components. So we need to split this force into two components. Both should be at right angles. So the way to do it is, from the head, drop a vertical line. Now if you see, this vertical line cuts the horizontal at a point. So the horizontal component is from the tail of this arrowhead, which represents the tension in this cable, to the point where it intersects the horizontal, gives you the horizontal component. So that is how you get the horizontal component. And the vertical component, when added to this horizontal component, gives you the original tension of the cable, the original force. Do you see? So that's the way to draw the vector diagram in this situation. Now we have drawn this, so we know this is right angles since they are vertical and horizontal axis. They are parallel to vertical and horizontal axis, right? And now we know the angle between the force and the horizontal, and it is a right triangle. So we can use sine and cosine ratios to figure out the horizontal and the vertical component. So let's say that the horizontal component is fx and the vertical component is fy. In that case, fx is equals to cosine of 20,000, right? So we have fx is equals to the magnitude of fx is equals to 20,000 cos of 40 degrees. And the magnitude of the vertical component will be equals to, since it is opposite side, 20,000 times sine of 40 degrees. So that is how we can split or resolve a force into its rectangular components, right? So let's use calculator to calculate the answer. The answer is 3,000 times cos of 40 degrees gives us 15,320.8. So I'll write this as approximately 15,321 newtons. And the vertical component is 20,000 times sine of 40 degrees. That gives us 12,855.7. So 12,856 newtons. So that is how we get our components, right? So I hope this statement is clear to you. We did it like this. What is cos of 40 degrees? Let me show you here. Cos of 40 degrees is equals to adjacent over hypotenuse, which is fx magnitude over hypotenuse, which is 20,000, right? So from here, f of x magnitude is equals to 20,000 times cos of 40 degrees. And same thing we can do for Fy, right? So sine of 40 degrees will be Fy over 20,000. So Fy will be 20,000 times sine of 45, right? So that is how you get your components, right? I hope you understand now how to resolve a force into its components, especially rectangular components. Resolving into rectangular components is making a right triangle so that it starts from the tail and ends at the head of the given vector. And then you need to apply trigonometric ratios to find the magnitude of the components. I hope that helps. Thank you.